Hi everyone. In this video, I just want to run through an example of a Monte Carlo simulation, and I'm going to use Excel. So let's just go through the example that we did in class last week, and that was the Who Wants to Be a Bazillionaire game. So if you remember from class, we have a prize, we have a bonus multiplier, and then these two random numbers get multiplied to give us our winnings. The prize is uniformly distributed from 1,000 to 3,000. The multiplier is uniformly distributed, it's a discrete uniform distribution from 1 to 20. And then the two questions we want to answer are, what are the expected winnings? And what is the probability that the winnings will be at least $20,000? So my first column, I'm just going to create an index so I can keep track of the number of simulations that I'm running. And I know I need to generate a random number for prize. I need to generate a random number for the bonus. I need to calculate my winnings. And I need to answer the question, are my winnings greater than or equal to 20,000? That's the question. Since this is uniformly distributed from 1,000 to 3,000, I'm going to use this formula. I'm going to say that this equals 1K plus 2K times the random function. And so what this does is when the random function is 0, this cell is going to have a value of 1,000. And when the random function is 1, this cell is going to have a value of 3,000, and then all of the numbers in between. So let's make this money for fun. And then our bonus is a discrete uniform distribution from 1 to 20. So the formula I'm going to use is round up. And then I'm going to say it's 20 times rand. And I want to round this to an integer, so I'm going to say I want 0 digits after the decimal place. If you think about this using the same logic, this may not make sense, because if the rand function is 0, this is going to give you 0, and you're going to round it to 0. And when the rand function is 1, this is going to give you 20. So you might think that this is going from 0 to 20, but actually, if you remember from when Dr. Shia went over the probability review lecture, and then we're going to go over probability review again this coming week in lab. If you remember correctly, the probability that a continuous random variable takes a specific value, that probability is basically 0. It's infinitesimally small. So the probability of this number actually being exactly 0 is non-existent. So at best, this number might be very, 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 very close to 0, but it'll still be greater than 0. And so when we do a round up, it'll still round up to 1. Then we can calculate our winnings, and these are just going to be these two numbers multiplied. And then we want to answer this question, are the winnings greater than 20K? So we can say if these winnings are greater than 20,000, then we're going to say that it's true, and we're going to use the number 1 to indicate true, or else we're going to say it's false, and we're going to use the number 0 to indicate that it's false. Okay, and so now this is one simulated game. We played this game once, and we've simulated it, and we can simulate the same game twice. And then we can go ahead and simulate it as many times as we want, but for now, let's just simulate this game 100 times. So now we have here 100 games that we played 100 games, and we have different values for the winnings for each game, and we have different answers to this question of whether or not the winnings are greater than $20,000. And so now we want to answer our two questions here that we're wanting to know. We want to know the expected winnings, and we want to know this probability. So we want to know the expected winnings, and we want to know the probability that these winnings are greater than or equal to. Okay. So if we look at these two things that we want to know, we can find an estimate for the expected winnings by using the sample mean as an estimate for the expected value of the winnings. So we'll just use this formula average, and then it's from D2, we said 100, so it's D101. But since this is just an estimate of the true value, the expected winnings, every time we calculate, we play 100 games, we're going to get a different number. The sample mean is based on these 100 numbers. So if you see, I'm going to refresh, I get a different number, refresh, I get a different number. So each time I play 100 games, I'm going to get a different sample mean. So it is not sufficient to simply say, oh, my expected winnings are $20,835.13. I need to give some sort of a range. We're going to calculate a confidence interval around this point estimate. And let's calculate a 95% confidence interval. So to do that, we need to know the sample standard deviation. I'm just going to abbreviate this. Standard deviation, and the formula for this is STDEV.S. It has to be .S because it's a sample standard deviation, so that's D2 to D101. And then if you remember from the formula for confidence intervals, we also need to know our sample size, which in this case is 100, and we need to know our z-score, and for a confidence interval of 95%, we need to know the z-score at 0.975. We need to know the 97.5th percentile value. And if you're a little confused by this concept, we'll cover it in our probability review session this week. So some of you may know that this value, this z-score, is 1.96 approximately. If you don't know that, you can look it up on a table. There's a table in our textbook. You can also just do a Google search for z-table, and you can find a table. You can also use Excel. So I'm going to do a normal standard inverse at the 0.975 level. And so this gives me approximately 1.96. And so using these three values, I can now calculate a half-width. So the formula for half-width is my z-score times my standard deviation divided by the square root of my sample size. And so now this then can let us calculate the bounds of our 95% confidence interval. So let's do the upper bound, lower bound. I want this to be capitalized. And so this is just going to be my sample mean plus my half-width. And my lower bound is going to be my sample mean minus my half-width. So now we have a range of values around my sample mean, and this is now sufficient. This is what we can present. We can present the sample mean plus or minus our half-width, or put another way, a range, our lower bound and upper bound for our 95% confidence interval. So now this answers the question, what are the expected winnings? So our second question, what is the probability that the winnings are at least $20,000? So we can look at this, and to find the probability that it's at least $20,000, we're going to see the number of times that it was greater than 20,000 divided by the total number of times that we checked the answer to this question. So because of the way this is coded between zeros and ones, if we add up all of the values, it's the same as counting the number of times that this was greater than 20K. And if we divide by the number of times we ask the question, which is our n, we'll have this probability, and that is just the formula for sample mean. So we can just use the sample mean formula of this random variable in column E, so it's E2 to E101. And now this gives us a point estimate for the probability that our winnings are greater than 20K. So it's a little less than half. And then we can do the same calculations for, this should stay 100, for this metric as well. Remember that this is still just an estimate based on this sample, so we can't just say the probability is 0.47. We have to give a range of values around this sample mean. So we have a range of values that's going to be 0.47 plus or minus this 0.098 number. So we can now just calculate that. So that's going to be our mean plus our half-width, and this is going to be equal to our mean minus our half-width. And so now we have a confidence interval for this probability. So that's it for this simulation. You'll find that your simulation, the columns of your simulation, depending on what the questions are, might be very different, but these summary statistics will always be pretty similar. We'll always have some sort of expression to tell us what we're trying to answer, and then since it's based off of sample data, we need to also provide a confidence interval. Thank you for watching this video, and I hope you found it helpful.